You have seen it happen and probably walked right past it. A toad at the edge of your garden bed, pressing its body against the soil, working itself down into the loose earth until only its head shows above the surface. You assumed it was looking for moisture, looking for shade. You kept walking. That moment is worth stopping for. What a toad does when it selects a patch of soil and presses itself into it is not a random act. It is an evaluation. And a garden that passes that evaluation is telling you something about itself that no soil test will give you. For most of recorded history, toads were filed away as omens, pests, or just background texture in the garden picture. The science tells a different story. A toad choosing your soil has a specific checklist, and the conditions it requires to survive overlap almost exactly with the conditions that define a healthy, productive growing environment. It did not find your garden by chance. It found it because something there is right. Understanding what that is changes how you see everything else that happens in your beds. We are going to follow it into the ground and find out what it is reading. If you're enjoying this so far, hit the like button and subscribe. It genuinely helps. Drop a comment telling me where in the world you're watching from. I actually read them. The assumption most gardeners carry is that toads appear near gardens the way pigeons appear near parks, drawn by general conditions, attracted to moisture and cover and proximity to water. In this picture, they are opportunists. They show up when conditions are vaguely suitable and move elsewhere when they are not. Research on American toad behavior does not support that picture. Studies tracking Anaxyrus americanus across multi-year periods using mark recapture methods have documented individual toads returning to the same garden plots from distances of several hundred meters. They come back season after season, guided by olfactory memory built from years of prior visits. The toad in your garden this summer may not be a new toad. It may be an animal that has been using your bed longer than your current planting scheme has existed. What draws them initially and what keeps them returning is a specific kind of soil ecology. Toads need ground loose enough to press into during the hottest afternoon hours, when their body temperature would otherwise climb past a survivable threshold. They need cover from low plantings or leaf debris. They need the invertebrate populations that thrive in undisturbed, organically active soil. Each of those requirements points toward the same condition: ground that has not been heavily compacted, stripped, or chemically saturated. A toad cannot settle into compacted earth. It cannot thermally regulate in soil leached of moisture-holding organic matter. When it chooses your bed, it has already determined that your soil meets the threshold. That determination is not casual. Before considering the toad as a pest control mechanism, consider what its presence already tells you. Soil that supports a returning toad population has maintained a certain kind of biological activity: the worm density, the moisture retention, the loose, undisturbed structure that allows invertebrates to thrive year-round. You cannot have the toad without those conditions first. When you see one settling in, you are looking at an animal that found what it was looking for. A single adult American toad, across one active season, can consume more than 10,000 invertebrates. Stomach content studies from wild-caught specimens across the northeastern United States have consistently documented a diet weighted heavily towards slugs, which move on or just below the soil surface after dark, toward cutworm larvae, which sever plant stems at soil level, and toward the beetles and earwigs that work through foliage through the night. The toad hunts by motion detection. It sits still for long periods. When something moves within roughly 15 centimeters, the tongue fires in approximately 150 milliseconds, and the prey is swallowed before it has processed the strike. This happens repeatedly through the active hours, which run from dusk through the first few hours of darkness, precisely the window when slug activity peaks. Slugs emerge most heavily in the 2 hours after sundown, when surface temperature drops and dew begins to form. The toad has been in the soil since midday, body temperature held against the cool earth, and it surfaces into exactly that window. No spray application matches that. A pesticide applied once a week addresses what is visible when you are standing in the garden in daylight. The toad addresses what is moving at 2 in the morning, in the hours when the damage actually happens. The garden that gets sprayed on a fixed schedule runs a permanent deficit. The slug population collapses and then returns. The pesticide is reapplied. The invertebrate predators that would have stabilized the system never establish because the conditions they need keep being reset by the next application. If this is making you think, subscribe and turn on notifications so you never miss one. This channel only exists because of the people who share these videos, and I don't take that lightly. The complication is in the skin itself. Amphibian skin is permeable. A toad does not drink through its mouth. It pulls water in through a patch of ventral skin pressed against damp ground, called the seat patch, which allows moisture to cross directly into the bloodstream. This is what keeps it alive in dry conditions. It is also what makes it vulnerable to whatever the soil around it contains. Pesticide residue does not stay where it lands. It moves into the moisture layer of the soil, and that moisture layer crosses through the toad's skin continuously. Ecologist Rick Relier at the University of Pittsburgh published research between 2005 and 2008 demonstrating that amphibians could be harmed by pesticide concentrations considered safe for other wildlife, with dermal absorption playing a significant role in that exposure. The animals in those studies were not eating anything treated. They were absorbing it through contact with contaminated ground. A toad that has been using your garden for years is absorbing the chemical history of your soil every time it settles in. The animal that appears to be resting is, at that moment, in unbroken contact with every application that bed has received. This is why the act of returning matters so much. The multi-year return patterns documented in mark recapture studies only persist where soil chemistry stays stable enough for the toad to survive season after season. A garden treated heavily will see its toad population disappear across 2 or 3 seasons. The toads stop coming back. The gardener assumes they have moved elsewhere. The actual reason is quieter than that. Chytrid fungus, a waterborne pathogen carried in soil moisture and standing water, has driven amphibian population collapses across 6 continents. It is now present in wild toad populations across North America. Biologists studying global amphibian decline estimate that roughly 1/3 of all species are currently in measurable decline worldwide. The toad pressing itself into your soil is living in a world where its kind are disappearing from landscapes that look, on the surface, entirely unchanged. A toad returning to your garden in this context is not background scenery. It is a sign that your particular patch of ground has stayed viable when adjacent ground has not. That viability is not permanent, and it is not self-sustaining. It depends on choices you are either protecting or eroding with every decision you make about what goes into that soil. What the toad needs from you is simpler than most conservation guidance. Stop applying broad-spectrum treatments to the beds it frequents. The chemical residue accumulates in the soil moisture it absorbs daily through its skin. Leave a section of ground undisturbed, loose, and partially shaded, with leaf debris or low cover nearby. This is exactly what the toad is evaluating when it settles into your bed in the afternoon. If you use slug bait, iron phosphate formulations carry considerably less risk to soil amphibians than metaldehyde-based products, which have documented toxicity at the soil water level and persist long enough to reach animals that never contact the bait directly. Consider what the bait is replacing. The toad working through your garden after dark is not a supplement to slug control. In a garden with an active toad population through most of the season, it is the slug control. The bait addresses the symptom at the surface. The toad addresses the source below it. In the soil, the slugs shelter in during the day. The toad that has been returning to your garden for years knows this bed. It came back to that specific corner because something there met the threshold it was looking for: the loose soil, the damp morning shade, the absence of chemical barriers accumulating in its bloodstream through the night. It chose your garden from all the available ground in its territory and kept choosing it. That choice is information. It tells you something about your soil that a test kit measures in numbers but cannot describe in terms of what is alive down there, moving through the dark, keeping a balance you would otherwise have to manage yourself, with treatments that have to be reapplied because they do not last. The toad lasts. It returns year after year. It works through the night, and its presence tells you that your garden has held something worth holding, something that is becoming harder to find in gardens that look similar from the outside. The next time you see one pressing itself into your soil, The useful response is not to spray or to shoo it along. Go inside. Turn the porch light off. Let it do what it came there to do. And tomorrow morning, when the garden looks untouched and quiet, understand that something was working out there all night on your behalf. Thank you for watching until the end. If this changed how you see something, check out the videos on screen. I think they will hit the same way. And subscribe if you haven't. See you in the next one.